it comes to transformations, what are the transformations we have?
Um,
Can you tell me?
Horizontal and vertical.
Okay,
Remember
yeah.
that?
So whatever transformations we are learning, we'll have both ways. Horizontal we will have, vertical we will have. In which case, because here in the Cartesian plane, isn't it? In Cartesian plane, you will have horizontal and vertical because um, we have with respect to x-axis, with respect to y-axis. Like we have, since we have two variables, we'll be having two. Okay, so here this transformations is basically like the change or okay, so if you have a function y is equal to f of x, how can we say transformation of this function? It means like there's a slight change in the graph of this function, isn't it? Maybe it can be its position, the change in its position, or it can be the change in its size. Is it clear?
Yeah.
Or the shape, yeah, or the shape. So three ways we have. So the first transformations we have is translation. Translation means a change in its position, like we are shifting the graph, so we are lifting it. So this graph, suppose is one graph, and I'm shifting it to a new place. So I can shift it two ways, isn't it? Either I can shift it horizontally or I can shift vertically, isn't it?
Yeah.
Okay, fine, yeah. So this translation.
I think someone joined the meeting. I'm not sure. Oh, then they left.
Sorry.
Someone joined and then left. I don't know who that was.
Maybe other classes are also going on, so maybe they joined in the wrong link.
Ah, okay.
Yeah. Okay, so we have horizontal translation and vertical translation. So in this horizontal translation, we are shifting it over the x-axis, isn't it? On the x-axis we have. So if you have, um, okay, y is equal to f of x, you have. Okay, so since we're shifting it in the x-axis, the change should be inside, isn't it? The change should be for the input. Is it clear? So when it comes to the horizontal translation, we have we always change the input. So suppose you want to shift, you're just changing it a little bit. So the transformation that I'm giving is the new function. Okay, let's take y dash. Okay, the new function y dash will be f of x minus h. So here this h is the shift, that is h is the shift of the graph. Okay, so here if this h is positive, which direction we do have when h is positive?
Left.
It's right. H is positive.
Oh. I thought like like it was like X plus something. It goes to the left.
I know. Always stick to one thing, okay? Because in that vertical scaling factor and all, it might change. The standard way is f of x minus h, then h is positive. Is it clear?
Yeah.
Okay. One example I can give you. See, if, you have learned solving quadratics, and there you have factorization, right? So we
Yeah.
always factor it like this: x minus a times x minus b, and from here we take x is equal to a is the root. Okay. So we always took minus, isn't it?
Yeah.
Okay. So what I was trying to say is that this is the standard way. Okay. So here you take h is positive. Okay, stick to one way, else it will be confusing. Okay, so if you're writing the way that you told me, you have x plus h, isn't it?
Yeah.
Yeah, then according, so which way you learned in school, this way or this way, the first
Well, I
one or
mean,
the
yeah.
second one?
Uh, the second one. So like, is there any way I
X
can write on
plus
the board
h.
too?
Oh, in this one, you won't be able to write in the
Okay.
board
Well,
because
I'll just put it in the
yeah.
chat then. So like, So you got a thing called like
And for the next class onwards, you can write. Okay.
okay.
So today I just opened this in this whiteboard. It's not the Zoom board that I'm using. Yeah.
Okay. Well, anyway, so like if so say you see this equation in the chat, right? Since it's a minus sign,
Mm.
it's be going to the right. So like the way they taught us that if this is
Yes.
a minus, it goes to the opposite side of what you might think it is. Because like
Mm.
you might think because it's -4 there, it goes to the left, but it goes to the right since there's a minus.
Okay, okay.
Like
So,
what I was thinking
okay,
when I
dear.
said that.
So, whichever way you're comfortable with, you can choose that. Okay, yeah. So this part you can choose like that. So just think, if you are making the change in the input, that will be horizontal. Okay, the change in the output will be vertical. For example, change in the output means you are calculating f of x. Okay, and then you are adding the shift. So it can be plus h or minus h. If it is plus, then we are moving up. If it is minus, we are going down. Is it clear?
Yeah.
Okay. So, sorry. Okay, now. So now, what is the next transformation that we have?
Um.
Easiest one. So we did
Dial
translation, shifting. Yeah. So after
dilations.
shifting, sorry.
Dilations.
Yeah, dilations. So how can we say? How to dilate a graph?
You have to have a coefficient almost. I don't know if I can explain it, but
It's like we are shrinking it
we're
or
shrinking
we
it
are
or we're
expanding it.
expanding it. Yeah.
Hmm? Sorry.
We're shrinking it or expanding it is what I was gonna say.
Yeah, shrinking or expanding. It depends upon the constant that we are multiplying it with, isn't it? So, oh, sorry. So next we have dilation. So in this dilation, similar to the shifting, in the horizontal, the change will be in the input, isn't it? So if you have y is equal to f of x, y is equal to f of kx. So the input I'm changing. In the vertical, you will be having y is equal to k into f of x. Is it clear?
Oh, okay. Yeah.
Yeah, where we are making the change. Okay, so here it's like you are making change in your input. Okay, so x is changed to kx, and then I'm calculating my function. Okay, in the vertical we have the other way around. We are calculating f of x, and then we are multiplying it with k. Is it clear?
Yeah.
Okay, so now here there are few possibilities. If this k is what happens if this k is greater than 1, or what happens if this k is less than 1. Less than 1 means 0 to 1. So k is, oh, sorry. What happens if k is 0? It's meaningless, isn't it? It's a zero function. If k is
I think
0, oh,
that it doesn't
sorry.
go up or down. If K is 0, it doesn't go up or down. Oh
If
wait,
k is
that's wait,
0, it's
wait. Oh, our my K in school is different.
sorry.
Usually, usually things in our school are it goes like A X plus H plus
Oh,
that's
the
how equations go.
constant.
Yeah, it's a different in my school.
Okay, dear.
Oh, you're
It's
doing
algebra, no? Yeah, so we can use any constant that you like. Okay, so if
oh
you want, we can take k. Okay, there is no problem. Hmm?
yeah.
So okay, fine. Yeah. So these are all like constants. So it's fine. So here we are taking x as input. If I want, I can take y as input. But we always we are used to using the same constants. Okay, sorry about that. Okay, because I didn't refer the book right now. I just wrote the constant that come to my mind.
Ah,
Okay, sorry about that. Yeah. Okay, so if this constant is 0, then our output is 0 irrespective of the input, isn't it? So here it doesn't have that meaning. It will become the axis. So we have k greater than 0. Okay, so please keep that in mind. We don't have an equal to here. And then the next one we have is like, what why don't we have an equal to here? It's because what happens if k is 1, if the constant is 1, there is no transformation, isn't it? We are getting the same graph.